In this video, we are going to see if a given carbonyl compound will react with Benedict's reagent. Now, carbonyl compounds are those that have a C double bond O. Now, these can be aldehydes in which a hydrogen is attached to a carbon, or they could be ketones in which the carbonyl group is attached to two other carbons or two other groups. Now, Benedict's reagent contains copper sulfate or copper in the +2 oxidation state. So Benedict's reagent is a mixture of sodium carbonate, sodium citrate, and copper sulfate pentahydrate. The key ingredient we are interested in is copper sulfate. You see that copper is in +2 oxidation state. Upon reaction with aldehydes, copper sulfate gets reduced to Cu2O, which is red in color. So Benedict's reagent is blue in color because of the presence of copper sulfate, and after reaction with aldehydes, the copper sulfate gets reduced to Cu2O and it's red in color. And the aldehyde gets oxidized to acid in the process. Aliphatic aldehydes and alpha hydroxy ketones react with Benedict's reagent. If we have an aromatic aldehyde, it will not react, and ketones also do not react. So the first example we have is acetone. Acetone is a ketone, so no reaction with Benedict's reagent. The next is formaldehyde. Formaldehyde is an aliphatic aldehyde, so it will react with Benedict's reagent, giving formic acid and red cuprous oxide. So the red color that you see is because of the formation of cuprous oxide from the copper sulfate that is present in Benedict's reagent. Next is propanal. Propanal is an aliphatic aldehyde. So with Benedict's reagent, we expect it to give a red color along with the formation of propionic acid. So this is formic acid and this is propionic acid. Benzaldehyde. Benzaldehyde has a benzene ring and an aldehyde group. Since aromatic compounds or aromatic aldehydes do not react with Benedict's reagent, we can expect no reaction. Next is vanillin. Vanillin is, again, vanillin is an aromatic aldehyde, so we can say that it should not react with Benedict's reagent. Now let's see glucose. The structure of glucose is so this is an aliphatic aldehyde. So with Benedict's reagent, it gives an acid, it gets oxidized. This is gluconic acid. Now fructose is this. You can see that fructose is a alpha hydroxy carbonyl because there is an OH group in the adjacent position to the carbonyl, and so it will react with Benedict's reagent to give a red color.